got y equals x minus 9 right, multiplied by x minus 3. So we've been told find dy dx. Basically, we have to differentiate this. So since we can see that we've got two terms here, all right, x minus 9 and x minus 3. So we know that we're going to apply the product rule, okay? Because we've got two terms here. So we know we're going to apply the product rule. And then since we've got x minus 9 and x minus 3 in brackets, all right, so we know we're going to also have to apply the chain rule. So two rules will be an application here, the product rule and the chain rule. So first what we're going to do is we're going to rewrite this. We'll say x minus 9 right? So the square root of x minus 3 is the same as saying x minus 3 to the power half. All right, x minus 3 to the power half. All right, so we're going to first apply the chain rule. All right, we'll apply first the chain rule. Okay, so we'll apply the chain rule to this and also the chain rule to this one. All right, so x minus 9, this is the same like as like to the power 1. All right, so we're going to say 1 times 1. All right, 1 times 1 gives us 1. All right, then we subtract our exponent there. We're going to remain with x minus 9 to the power 0. All right, x minus 9 to the power 0. All right, and then we also have to differentiate the term inside. We have to differentiate x minus 9. So to differentiate x minus 9, all right, we just differentiate it here on the side. Right, remember constant. Yes. All right, we see where all right, we've got two terms here, right? We've got two terms here, so we know what we're going to have to apply the product rule. All right, and then since these terms are in the brackets here, all right, we know we also have to apply the chain rule. Okay, so we're going to apply the chain rule and the product rule. So first we're starting with the product rule, so we're working individually. Okay, so the chain rule, all right, the chain rule is what I'm doing here. This x minus 9 is to the power 1. Okay, it's to the power 1. So we're going to say 1 times 1, all right, that is 1. All right, then 1 minus 1, that is 0. Have you seen this? How I've got 1 times x minus 1 to the power 0. All right, then we're also differentiating this x minus 9. We're also differentiating it. All right, so when we differentiate x minus 9, all right, we get 1. All right, because remember this is x to the power 1. So 1 times 1, that gives us 1. And 1 minus 1 gives us 0. So it's the same as saying 1 x to the power 0. Remember, x to the power 0 is the same as 1. So we just say 1 times 1. And that gives us 1. All right. So I'm just differentiating this x minus 9 in there, right? Multiplied by 1. All right. Multiplied by 9. All right. Right. Then, okay. Then we're going to leave our x minus 3 here, okay? Because in the product rule, what happens is you differentiate one, you leave the other one, then you differentiate the other one, and you leave the other one. Hope that's not confusing. Let me maybe put it down here like this. It will be like this: d dx right? So we're going to differentiate x minus 9, all right? We're going to differentiate x minus 9, but we'll leave x minus 3 to the power half, all right? X minus 3 to the power half. We leave it, all right? Then we say plus. So this is the product rule which I'm stating here, right? Plus, then we're going to derive x minus 3 to the power half. We derive x minus 3 to the power half, all right? And we leave this x minus 9 by itself, all right? This should have written this at first. Yes, all right. So here, that's what's happening here. We're deriving this x minus 9, right? We're deriving it using the chain rule, all right? Then we leave this x minus 3 to the power half. Then we derive this x minus 3 to the power half, and we leave the x minus 9, all right? So this is the product rule which I've stated here. Then the chain rule applies when we are deriving this x minus 9 and when deriving x minus 3 to the power half. Any questions? Yes. Okay, remember in indices, yes. X minus 1, x minus 3 to the power half. Yes. Okay, remember in indices, whenever we say x to the power a over m, all right, x to the power a over m is the same as the root of m, okay, and of x to the power a, right? For fractional indices, all right? For fractional indices, all right? A over m equals the root of m, okay? You put in x in the root and then to the power a. That's how I got this x minus half there, okay? Yes, that's how I got this x minus half. So yes, so this is the product rule here, which I've written down here, all right? You derive one term, all right? You leave the other one. So in this, at the first point, we leave the x minus 3 and half. We derive the x minus 9. Then you say plus. Then we derive the x minus 3 to the power half. And we leave x minus 9. Are we clear on that? Yes, don't worry. We'll go through these rules individually. Don't worry. This is just for the assignment's sake, but we'll go through chain rule and the power rule. So, upper we've derived x minus 9. All right. We say it's like x to the power 1. All right. We've done this part here. We've also derived the inside term, which is x minus 9. We've got 1 here. So are we understanding how this x minus 9 to the power 0 times 1 has come about? Are we understanding how that has come about? Okay, we'll get the concept, don't worry. Yes? That one is a little bit clear. It's a little bit clear, okay. Yes, I've gotten the concept where one open bracket x minus 9 to the power 0 coming. What about times 1? This times 1, because we've also differentiated what's inside here, x minus 9. We've differentiated it also, okay? When you're using the chain rule, you're going to derive 2 times, all right? You derive outside, all right? As we did here, 1 times 1 becomes 0 here. This one comes. We've derived outside. Then we also derive inside. All right, that's where we derived x minus 9, and that's how we got this one. All right. All right. So let me just, because this is for your assignment, so you have to put it in steps. Let me just put the power rule just here so that it's looking clear. All right. Let me just put it under there so that it looks clear. Okay. So let's hold on. We put it like this. We say do what? We put it like this. Okay. You put d dx x minus 9, right? Then we will leave this x minus 3 the way it is, just x minus 3 to the power half. We'll leave it. Plus d dx. Now this is where we're going to have to derive the x minus 3 to the power half. All right, x minus 3 to the power half. In brackets x minus 9. Right, like that. So as I said, as we derived earlier on, okay, we're deriving. So this in yellow is the product rule. Now we're applying the chain rule, okay? So the chain rule here, 1 times 1, we get 1, open brackets, x minus 9 to the power 0, right? Then we also derive what's inside. So when we derive x minus 9, that gives us 1. So that's how this times 1 has appeared, right? Then just put this in brackets, okay? Then you leave x minus 3 to the power half the way it is, all right? You just leave it. Plus, all right? Now, here, this is where we're now going to derive x minus 3 to the power half, all right? So, half times 1, we're going to get half, all right? So, we'll have half, all right? Then half minus 1, we get negative half, all right? So, we'll have half x minus 3 to the power negative half, all right? Then we derive now, inside here, we derive x minus 3, all right? So when we derive x minus 3, we still get 1, okay? Because remember, this is like x to the power 1. 1 times 1, that is 1. Then if we subtract 1 minus 1, we get 0. So we have 1 times x to the power 0. And x to the power 0 is the same as 1 times 1. And that's how we get this one here, which I'm putting times 1. Okay? Close brackets, then you leave x minus 9 here. Okay. Any questions? Any questions? Wonderful. X minus 9 to the power 0 is 1. Okay, x minus 9 to the power 0, this is 1. So we say 1 times 1 times 1, we get 1. Times x minus 3 to the power half, we just get, we remain with x minus 3 to the power half. All right. right? X minus 3 to the power half plus, all right, plus, all right. So here, let's see, x minus 3 to the power half is the same as 1 over x over 3. We're going to say half times 1 over x minus 3 to the power half. Okay, remember the law of indices. When we have negative indices, oh, it won't be negative this time. So this is below the 1, so it's half here. All right, the power half. All right, the power half. All right, times 1. All right, times 1. Okay, and we'll leave our x minus 9 here. All right, so we operate in these brackets here. We're going to get 1 over x minus 3 to the power half. All right, times x minus 9. So x minus 9 will just come on the numerator, okay? This x minus 9 will just come on the numerator. We have x minus 9 over x minus 3 to the power half, all right? When we multiplied this out, all right, we had 1 over x minus 3 to the power half. And when we multiply by x minus 9, we have x minus 9 as the numerator, okay? So do not worry, second year you won't be dealing with this stuff. It's only first year, okay? Second year, you'll be saying bye to this stuff, all right? So we have x minus 3 to the power half plus x minus 9 over x minus 3 to the power half, all right? Then we can leave it in this form. We'll have x minus 3 plus x minus 9 over, oh, there's a 2 here. This 2 here, sorry, forgot. There's a 2 here. Each. All right, this 2 and this half, this 2 here. So we have 2 x minus 3. All right, that is the answer.